Hello and welcome to section 6.4, using inverse functions. Good news for you guys today. You guys got a kind of a quick video, so shouldn't take too long. I think 15-20 minutes, ideally. But we do need to hammer a couple pieces of key vocabulary today. First one is this idea of an inverse. You've heard it before mathematically. Today we'll kind of explore what it is. Basically, the idea of an inverse is just the reverse of whatever happened originally. Here's my original relationship. I've got the x values, xy coordinates of 0, 6, 1, 4, 2, 2, 3, 4, 4, and negative 2. Again, the x values are listed right there in blue. The inverse function, or the inverse relation, all we do is flip-flop the x and y values. Which was once x, which was once y, becomes x. Which was once x becomes y. Notice that all I've done is flip-flop those values. The true definition of a word inverse is a reflection across the line y equals x. All right, so we're going to explore that idea today, the relationship between inverses. Specifically, we're going to flip-flop the x's and y's. So most of what we're doing today is finding its inverse functions and then verifying that they're an inverse. So I'll tell you how that works in just a sec. Here's the directions on what we're going to do. 2 steps. Take your original function, flip-flop x and y, and resolve that equation for y. Really, Mr. Wood? All I have to do is flip-flop x and y and solve for y? It's that easy? It's that easy. Here's our first equation. F of x equals the 4th root of x minus 2 plus 3. I'll give you a second to copy that down. Again, f of x equals the 4th root of x minus 2 plus 3. It says find the inverse. Mr. Wood, you said all we've got to do is flip-flop the x's and y's and resolve for y. There's no y in this problem. Sure there is. F of x is the same thing as y equals. So this says the 4th root of x minus 2 plus 3. If it asks us to find an inverse, then we're going to do 2 things. Flip-flop x's and y's. So x equals the 4th root of y minus 2 plus 3. And the next thing we're going to do, solve for y. X equals the 4th root of y minus 2 plus 3. Solving that equation for y. Work towards your y by first subtracting 3 from both sides. That's going to give me x minus 3 equals the 4th root of y minus 2. Now, when you move that 3 over, what I encourage you to do, please put parentheses around that term, because I need you to keep that negative 3 connected to that x, and here's why. At this point, I need to get rid of a 4th root of y minus 2. The way that I get rid of a 4th root of y minus 2 is raise both sides of this equation to the 4th exponent. Remember, I can do whatever I want in an equation as long as I do the same thing to both sides of the equation. Mr. Wood, it seems like you pulled that 4 out of thin air. No, I did not pull that 4 out of thin air. I wanted to know what would get rid of the 4th root. What gets rid of the 4th root is an exponent of 4, because the 4th root of y minus 2 to the 4th power will simplify to just y minus 2. Another way to see that visually off on the side over here, that says y minus 2 to the 1/4 exponent, because remember the 4th root is 1/4, and then I raised it to an exponent of 4. We distribute that 4 in. 4 times 1/4 is 1, and we get our y minus 2. So on the left-hand side, I have x minus 3 to the 4th. On the right-hand side, I have y minus 2. Finish up this problem, add 2 to both sides. So y is going to equal x minus 3 to the 4th power plus 2. That's it. Here's how you write the inverse function. We say f negative 1 of x. That's just an abbreviation of the inverse function. And the inverse function is going to be x plus 3 to the fourth plus 2. I lied. It's x minus 3 to the fourth power plus 2. And that's it. All the directions asked us to do was find the inverse. We flip-flop x and y's and resolve. Finding an inverse function. Let's see. This says inverse functions. Function f and g are inverses of each other provided that f of g of x equals x and g of f of x equals x. Sorry for that. Pause. Let's see. Inverse functions. F and g are inverses of each other provided that f of g of x, that's a composite function. You should recognize that from yesterday's work. F of g of x simplifies to x, and g of f of x simplifies to x. And as I already told you, f negative 1, that's our abbreviation for inverse function. So, two things we're going to do on this next set of problems. We're first going to find the inverse function. After we find the inverse function, I'm going to verify that they're inverses of each other, and I'll show you how that's done. And the way that we're going to do it is function composition. So blending what we did yesterday with what we're doing today. Here we go. We've got the function f of x equals 3x to the fourth minus 5. We need to find the equation for the inverse and then verify that it's an inverse. So f of x equals 3x to the fourth minus 5. First thing I'm going to do, make that y equals. And now I'm going to flip-flop my x's and y's, set find the inverse. So that's going to become x equals 3y to the fourth minus 5. And then I'm going to resolve that equation for for y. First thing I'm going to do is add 5 to both sides. That gives me x plus 5 equals 3y to the fourth. Next part of this problem, I'm going to divide both sides by 3. That's going to give me x plus 5 over 3 equal to y to the fourth. How do I get rid of y to the fourth? Hopefully you're thinking we'll do something like this. Take the fourth root on each side of the equation. Remember, I can do whatever I want to an equation as long as I do the same thing to both sides of that equation. So on the left-hand side, I have the fourth root of x plus 5 over 3. On the right-hand side, the fourth root of y to the fourth will simplify just to y. So my inverse function here is the fourth root of x plus 5 over 3. That's my inverse function. That's the first half of this problem. The second half of this problem said verify. So here's what I have to do. I have to do the function composition to verify that they're inverses. Okay? So I'm going to take that function that I have, and I'm going to verify it. Here's how that works. I'm going to do f of f negative 1 of x, and we're going to see how that works out. Okay? Once again, f of f negative 1 of x. This is a check. This is to verify that they're inverses here. F of f negative 1 of x. I have f negative 1 of x. I just found that, by the way. And f of x was given to us. So, let's see. F negative 1 of x is the fourth root of x plus 5 over 3. I need to find f of that. Well, f of x equals 3x plus 4 minus 5. I now need to find f of the fourth root of x plus 5 over 3. That's the same thing as saying 3 times the fourth root of x plus 5 over 3 to the fourth power minus 5. Mr. Wood, that looks really ugly. I don't want to do that. It's not that hard of a problem. Let's see if I can move this. Can I move that? I'll move that over here. I'm going to keep working over here on the right-hand side. And I'm going to simplify this. I've got the fourth root of x plus 5 over 3 to the fourth power. Hopefully you'll see right now in this expression, remember we work only the right-hand side, hopefully you'll see that this fourth power and this fourth root will cancel each other out. So that's going to give me 3, and that fourth gets rid of that radical sign, x plus 5 over 3 here, minus 5. So I don't like fractions. It's not that bad of a fraction. That's 3 over 1. I have a giant 1 with these 3's. That's going to give me x plus 5 minus 5. X plus 5 minus 5 is just x. Well, didn't I tell you that when we did composite functions, if they were inverses, it would simplify to x? No, you did. So it does simplify to x. So f of the inverse function, in this case, f of negative 1 of x is x. That's the first condition. That checks out. That simplifies to x. We need to do both. I verified it one way. I now need to verify it the other way. F negative 1 of f of x. This time I'm going to start with f of x. Say it with me. F of x equals 3x to the fourth minus 5. F of x equals 3x to the fourth minus 5. I need to find f of 3x to the fourth minus 5. Function composition. I now need to stick 3x to the fourth minus 5 into my inverse function over here. F of x, f negative 1 of x equals the fourth root of x plus 5 over 3. I need to find, f negative 1. I need to find f negative 1 of 3x to the fourth minus 5. That's going to be the fourth root of 3x to the fourth minus 5. There's me substituting in for that x right there. Then I'm going to add 5 to it, and I'm going to divide by 3. Simplify. Work from the inside out. Remember, we're only going to work the right-hand side. That is the fourth root of 3x to the fourth minus 5 plus 5 divided by 3. That is the fourth root of 3x to the fourth over 3. Plus 5 minus 5 goes away. I have 3x to the fourth over 3. I got a giant 1 there. I now have the fourth root of x to the fourth. The fourth root of x to the fourth is just x. It's simplified to x. Oh me, oh my, I am shocked to see that both f negative 1 of f of x simplifies to x, and the f of negative 1 of x simplifies to x. When this happens, when they both check out, you have inverse functions. We have verified that those are inverse functions. You need to do both. Find the inverse and then verify. You guys, I want you to do this problem. F of x equals 3x to the fifth minus 2. I want you to find the equation for its inverse and then verify that those functions are inverses. Now is when you want to pause the video, get that problem done. Again, find its inverse and then verify that they're inverses. When you're done, go ahead and unpause the video, and I will pick up on our last problem, I think. Okay, hopefully you got done at that checkpoint. Here's the last problem we're going to do. Fitness. Elastic bands can be used in exercise and provide a range of resistance. This is also out of your textbook, so if you don't want to copy this problem down, you can look in your textbook. band's resistance R in pounds can be modeled by the equation R equals 3/8 L minus 5, where L is the total length of the stretched band in inches. Find the inverse of the model. I recognize that word. I know how to do that. Use the inverse function to find the length at which the band provides 19 pounds of resistance. Okay? So, find the inverse of the model. R equals 3/8 L minus 5. All we have to do is flip-flop x and y's. In this case, we don't have x and y's. So all I'm going to do is solve this equation for L. First thing I'm going to do is multiply both sides of this equation, add both sides of this equation by 5. That's going to give us R plus 5. Again, you're probably asking, why didn't I flip-flop the R and the L in this case? The reason we flip-flop the x's and y's is because we're looking at the relationship between x and y's on our coordinate plane. In this case, we're looking at the relationship between R and L. I'm not really graphing these. So I'm just going to solve this equation for L. Let's see, R plus 5 equals 3/8 L. I will now multiply both sides of this equation by 8/3, multiplying by the reciprocal to get L by itself. So L is going to equal 8/3 R plus 5. So in other words, the inverse, if resistance is R equals 3/8 L minus 5, then length is going to equal 8/3 of R plus 5. It says use that function. We found it. It says use the inverse function. That's what I have here. To find the length at which the band provides 19 pounds of resistance. Find the length, find L, when there is 19 pounds of resistance. So substitute 19 in for R, solve the equation for L. So how big is the length? That's going to be 8/3 times, let's see, 19 plus 5 is 24. That's 24 over 1 is a fraction. All I have to do is reduce this fraction. 3 goes into 3 once. 3 goes into 24 8 times. I'm left with 8 times 8, so that answer is 64. So in this case, the length will be 64, I think inches. What does it say? Inches? Yep. 64 inches. Inverses, verifying, using inverses to find a new distance, and you got it. Told you it was going to be a short video today. Good luck. See you guys tomorrow.